Hello everyone, good evening, and thank you all for joining us today. I am Parth Varu, event planner at Microsoft Reactor Bangalore. This session will run over next 60 minutes, including Q&A. The session is being recorded and will be uploaded to our Reactor YouTube channel. I will share the link to our YouTube channel in the chat section soon. Before we begin, please take a moment to read our code of conduct. We are all here to learn together, so please be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat will be open throughout and we do encourage you all to participate. Also, please keep your mics muted during the session. I would now like to welcome Shivam, our speaker for today's session. Shivam is an author, cloud architect, speaker, and co-founder at TechScalable. Being passionate about ever evolving technology, he works on Azure, GCP, machine learning, and blockchain. He is also a Microsoft certified trainer. As of now, over to Shivam for the session.
Thank you, Parth. I'll share my screen. Okay, so welcome everyone. Hopefully, all of you are doing well. All of you are safe as well. And today we will be discussing about what is machine learning for, or you can say what is DevOps for machine learning, which we call as MLOps, and what are the DevOps practices which we use as part of machine learning projects. What are the best practices? What are the core principles which you have to implement in the MLOps pipelines, and what is what are MLOps pipelines, and so on and so forth, right? So we will discuss all of that. Now, before we jump into it, I will take you through the learning module which we have. So if you go to the meetup page, if you just scroll down and you find the further learning module here, and if you just open that, it will take you to uh, the MS Learn page, where you will find that whatever we'll be discussing will also be available in a very structured manner, like how can you work with these pipelines and so on and so forth over there. And you can simply sign in from the top, and you can even save your progress. If you do that, you can follow these steps. There are some exercises there, and if you go maybe a few pages back over here, you will also be able to find the you can say the landing page, where you will find even more steps over there, like that, right, where it will involve. So those who are new to the machine learning itself can also just go one page back and see the entire learning path over there, and you will find all the details as such. It will cover the end-to-end deployment of the model with data drift monitoring and the security concepts and so on and so forth in Azure Machine Learning Service. Now, these links are also in the chat window. You can bookmark them from there. Now, what we will do, we will jump into the topic for the day, MLOps. We will understand what is MLOps, how is it different from DevOps, what are the extra things which happen over there, and what are the challenges with which we face, and how do we solve it. I will provide you some with the enterprise templates which we use for MLOps projects. These templates are provided by Microsoft, and we use them as the baseline, and then we customize them whenever required. So I will show you how it's that done. How can you customize those templates, and how can you accelerate your MLOps projects as such? What are the standard directory structures? What should you know, and so on and so forth? All of those type of things we will discuss. So let's get started from somewhere. So the very first thing I just want to take your attention to, or put your attention on, is will be the challenges which we face in machine learning. Uh, for example, the and most of these challenges which we are facing will be due to lack of you can say, coordination between the teams, or maybe the data is coming from various different the data is available in different sources and different silos in different teams as such, and because of that there is lack of coordination between them, or the process is not standard or repeated as such. So whenever any data scientists create the machine learning model, the deployment of the model and the entire process needs to be done again and again from scratch, something like that. Maybe another challenge which companies are, or these are the challenges which which Microsoft has identified, which companies are facing right now. A lack of resources as well, like lack of both human resources and technical resources as well. That's another thing which is causing challenges in the ML machine learning projects. Auditability is another problem, like things should be trackable, documented, audited, uh, and lack of explanation of the models becomes another problem, which we all will be able to, you can say, we can all of these problems will be answered, or will be, uh, you can say, we'll solve them as such in this session itself. Now, a couple of things. So I will use unlike my previous sessions, I will use more of my whiteboard over here to, you can say, explain stuff. Now, there is one difference, or there are a couple of, you can say, fundamental differences between the DevOps pipeline and MLOps pipeline. Will be in will be the very first thing is that in MLOps pipelines or in machine learning, what happens versus any of your traditional application development or any other development process which you are doing right now, or maybe which is done in any company. One of the fundamental difference between these two will be that the machine learning models or the machine learning projects may not even, uh, you can say, may not even go into production. So what happens is the first step in, you can say, in the machine learning or in the data science project will be the exploration step over there, where we explore that is it even possible to be done. Like there is a problem statement. So what will happen? The business will provide you the problem statement that, let's put business over here. So imagine the business owner is here. So he provides you the problem statement. Okay, then we have to do the forecasting, or we have to do some sort of prediction, or maybe you want to do preventive maintenance for that. This is supposed to be done. So the business problem will be there. Now, for that business problem, you will gather some data. Now, the data which is provided to you or which you are able to gather may or may not. So you gather data and then you start exploring the data. So let me put the data scientist over here. So data scientist starts exploring the data itself over there. Now, in the very first phase itself, it will be clear, or the conclusion will be made that using the data which is available, is it even feasible? Is it even the data science project? Is it even feasible to provide the return, or to provide the value which the business is looking for? So if it is decided that on this phase itself that this data set is not sufficient enough to meet the requirements of the business, that's the end of the project over there. But this is not what happens in any other application development. Like if you think about any other project itself, if you want to make your company's website or any application, the development process basically starts, and then you may take some extra features or not in production. But the very first thing which happens in the data science projects may just finish the project there, and in that point itself. So so here, if we just put a couple of more points, the problem statement will be discussed over here. The problem definition, the data acquisition happens, understanding of data, the process called as EDA, exploratory data analytics also happen, and then we assess the project whether it's feasible or not. If it is feasible, if we finally decide to take it forth, right, then the next step starts over there, which we talk about as experiment and develop. So this is where we do the experimentation. Let's say experiment, and we start with the development of the, you can say, the model creation will start over here. So develop. Now the phases here will involve the model selection, feature engineering, tracking and the validation of the model, testing, automation, and then comes the operations. So we have to, let's say, operate. So operate will involve the, if I let me just put few words over here. So this will involve the model serving of the models. Now this will also involve the data drift monitoring. We'll discuss what is data drift monitoring. We'll go through it. So in a nutshell, data drift monitoring is about understanding when your model is getting degraded in you can say production. Now retraining of the model. So retrain will also come, and the generic monitoring of the all the different matrices which are there. The simple generic monitoring of it. So now in the experiment and develop phase over here, the model selection will come. This is where model selection happens. And we also do the feature engineering here. The feature selection also happens here, which is the best feature to be taken. New features will be generated over there, will be stored, and so on and so forth. And then after that, the tracking of the and the validation and testing and automation. So test, automation, like that. So the exploration step is something which is totally added in the MLOps pipelines. And then over here, this goes back like this. And then we are talking about continuous experimentation. So continuously the models can be trained and so on and so forth. So this goes something like that back again. Now, if I go in more depth into what we have just discussed, right? This is just a very high level overview of what we will be doing. So if I just go in more depth, there is a particular, there are various different type of you can say approaches which we take when we start with any data science project. So one of the approach which Microsoft suggests is the team data science process. I'll just give this link in the chat. So let me put it over there. And on this, and let me just zoom in over here. So this is the process which Microsoft also takes internally when they develop these solutions for us, and this is one of the process which they are recommending as well, and with the pros and cons of it. So the data science lifecycle starts from the business understanding over here, like that, and then the collection of the sources, data acquisition and understanding, like we were discussing. Data sources are decided whether they are on premises or in the cloud. Is it a file data set or is it a table, or are there files as such? The pipeline will be like a streaming pipeline. Data will come over streams, or will it be pulled over by any ETL tool over a schedule? Is it high frequency or low frequency? What type of environment will be used? Is it on premise, in the cloud? Are we going to use big data scenarios? So are data lakes over there, or relational databases will be there? Is it small, medium, or big data? Then comes the wrangling and the exploration and the cleaning as such, as part of data acquisition and understanding. This is everything is happening in the just based on the business on the data set which is provided, and trying to we are trying to do the assessment whether this project is something which is even feasible for the to you can say to meet the business requirements. Is it structured, unstructured? The cleanup of the data, visualization of the data. Then modeling also is there. As part of modeling, feature engineering, model training, model evaluation. So transformation of the data, feature image data needs to be processed, feature selection needs to done. We select the correct algorithm. We may do hyperparameter tuning, retraining of the models, validation of the models, and then the deployment of the models as well. And as part of deployment, the monitoring and so on and so forth, and the acceptance by the customer. So this process over here, this flow is called as team data science uh, process lifecycle. And this is one of these standard lifecycle. Apart from, there are a couple of other you can say lifecycle over here: CRISP, DM, and KDD. On that link, it's in the chat window. You can go and read about them. How are they done? Now, as part of this team data science process, there are a couple of very well-defined steps, or very well-defined uh, you can say job description is there, where we involve the solution architect, the project managers, data engineers, data scientists, application developers, and the project lead over there. So if you go to that page, you will also find this detailed or you can say the division of the where the division of the roles and task is done. So on the left hand side you can see project lead, data scientist, project manager, solution architect, and then on the top various phases are there: business understanding, data ingestion, modeling, the deployment, and the acceptance of that particular project which you have done. So if we think of from the data scientist point of view, see over here. So basically, data scientists will be taking care of the any like the provisioning of the compute asset. Like for example, are they going to use the Spark based training solution, or are they going to use CPU or GPU? The data will be ingested, will be given to them, exploration of it. The blue ones are the task, the green ones are the artifact, the output of that phase. So the output of this phase can be of this data ingestion and understanding phase will be like the summary report of the data itself, like what is this data about and all the details over there. Then as part of the modeling, the output may be the model report over there as such. Now as part of the deployment, the output can be the dashboard from the, and this is expected from the data scientist to be able to monitor the health and the metric of the model. Now and if I just scroll up, zoom out, you will notice that we have other players as well, the solution architects over here who will design the solution, and then the project leads are there who will provision the data infrastructure, who will make the checkpoints for the projects and will do the transition to the production support of that particular project over there. Now, and other things are also there, that what project managers are supposed to do, and so on and so forth. So if your company is following the standard way of data science, then you can also use this GitHub repository over here, where they have provided the directory structure for like the baseline directory structure. You can differ from it, but the baseline can be used, like the project names, the data folder, doc folder, code folder, then raw data, process data, modeled, project data reports, models, experiment 1, 2, 3, 4, and the data preparation folders and different type of folders are there, which can be used as the baseline over there. So it's available on this page. Now, apart from this, let me just see if there is anything else over here which I want you to see. Okay. So this link is there in the chat window, right? In case you want to have a look at that. Now, there are a couple of principles which we should always follow. And there are some best practices apart from that. So let me just put the principles down. And then after the principles, I will tell you the best practice and I will show you the process of how it's done as well. Right? So there are 7 principles, and these 7 principles are very you can say are summarized and generic, and all the MLOps uh, projects should have them. Or whenever you're, it's not even about MLOps. It's just if you're doing machine learning, and if you want it to be standardized, you should have these best practices over there to be followed. So 7 principles are there, and let me put these 7 principles, and we will discuss these 7 principles. I'll show you in the code also how you can implement them, right? And these are pretty, some of them are very generic, which you can simply, you may already be aware of these. Like one of the very common thing is the version your code. But machine learning is not only about code, it's about data as well. If the data changes, the output is totally different. And one of the thing which we face, or one of the challenge, if you remember, is about reproducing the same machine learning model, or having the trackability, or the ability to get that same thing again and again and again and again, because machine learning has that problem where the output of two subsequent run may not be same. So how do we make it same? So we have to version the data, the code needs to be versioned, and the outputs need to be versioned as well. Now another practice is about using multiple multiple environments. Like this is very generic, like the in DevOps we have, if you think about the CD, the continuous delivery. In continuous delivery, we have the testing and the then the some sort of UAT, and then in as part of deployment the production environment. So similarly over here, it is must that you should have multiple environments which should be similar, but should be but you should have at least multiple of them. So for example, one for the development purpose, one for testing purpose, and let's say one for prod minimum. Now apart from this, infrastructure as code. The This is another, you can say, core principle which should be there in the MLOps or in the DevOps for ML machine learning pipelines or in projects. Now infrastructure as code will help you with the reruns. You will be able to rerun things. You will be able to version control the environments as well. You can do that, and you will be able to move your environments, or you move your model across multiple environments, and you will be able to manage those environments with IAC. So now apart from this, I have the detailed list as well of this, right, with all the details. But when I'm speaking, I'll share you that detail as well. I have all these five, six links which I want to share with you noted with me. I will put them in the chat as soon as we sort of go through them. Now, another very important thing is tracking of the experiments. So now when we talk about tracking of the experiments, we talk about the performance KPIs, we talk about the artifacts of the machine learning experiment, the history of the experiment itself, the like was it successful, how was it created, the details over there, and so on and so forth. The next thing is testing, obviously testing of the code, testing of the data, the integrity of the data, the validity of the data. When if you're using any type of tool for ETL purpose, it's possible when you move the data around across multiple system, physical integrity may get compromised of the data. Some sort of schema drift may happen. So you should have some sort of, you can say, you need to take care of that. Now, apart from it, uh, so the model quality over there. Apart from it, the another principle, the sixth principle will be the obvious one, the CI and the CD. If you can automate it, it will be great. And the seventh principle will be of the monitoring. So everything should be monitored, the data and the models both. So data monitoring and the model monitoring. Now, apart from these seven principles, so these are supposed to be, you can say, in all the projects, there are best practices also. But before I go into best practice, I just want to show you one more thing. There are levels of maturity in the machine learning operations. And I'm just putting this link in the chat over here. So different companies, or you can do the assessment of your company yourself based on where your company falls in this maturity level. So we have five levels over here, 0 to 5 over there, 0 to 4, five levels over there. Now the first is no MLOps. The company doesn't do it. The problems will be very difficult, like difficult to manage the full life cycle of MLOps. It will be very painful for the teams to repeat the process again and again. Things will be, you can say, totally black boxes. Isolated environments will be there. Manual builds needs to be done, manual testing, and like so companies started with the machine learning but never implemented the MLOps practices. So manual builds, manual deployment, testing, no centralized tracking of the models, and the training of model will be manually done. So this is level 0, right? Level 1 will be DevOps but no machine MLOps. So you are following the DevOps practices, but the exploration practices and the best practice will be which we'll be discussing, those are not implemented. So the less painful, but still painful. Now the limited feedback will be there, difficult to trace and reproduce the result. Automated builds will be there, automated testing will be there, but rest is not taken care. As part of the maturity number 2, we say that this is the automated training of the models. So the environments will be uh, the models will be automatically trained whenever the data changes or whenever the code changes. The models will automatically train over there. We will be able to reproduce the same model even after months and months. You will, because you are versioning everything. Now the releases will be manual, but we will be having less friction right now. So automated model training will be there, centralized tracking of the model training and model management. As part of the model, as part of the third maturity level of the company, automated model deployment also. So not only the training, but deployment as well. So now full traceability of the deployment back to the original data. you have different environments, train, test, and production environment, which we were just discussing. You are doing A/B testing for the models. You are doing automated testing for all the code, centralization of the performance of the models. And this is the final maturity level of the companies, which we call as full MLOps or the full MLOps automated operations. So or level 4 maturity as per Microsoft's evaluation. So the full system will be automated and to easy to be monitored. The production system will provide information of on how to improve, and near zero downtimes will be there. So automated model testing and training, centralization of the metric deployment, and the retraining will also happen as part of this. So based on these, you will you can say internally, and if you have to evaluate any other company based on their MLOps maturity, this is the 5 levels which are used over there. And then we have more details of it, like what happens and what doesn't happen in each level. So link is there in the chat. You can go through the uh, through this and see what are the things which are there in the level number 4. So this is the demo which I'm just going to show you will be somewhere between level 3 and level 4. I'll show you the various things which data engineers needs to do, which software engineers needs to do, and so on and so forth over there. Okay, now few of the best practices. I will see if I can give you the exact you can say page in the chat window. So the practices are now going in the chat. So apart from the core 7 core principles which should be there, these are the best practices listed over here. We have the people practices and the process practices and the technical practices as well. So I'll take you to the process practices over here first. Now, uh, the when you do the experimentation of your models, the Jupyter notebooks which you write are not used as it is in production. We will not be able to, because that code is not that modular enough. The code is not having the ability to be reused, or it's not you can say having it's not object oriented enough. So standardization of the code is something which is one of the best practice. It makes it easy to be integrated as part of the CI pipelines or CD pipelines. Now, version control, it's pretty obvious. Versioning of the experiments input and output is very important. With every input, the output may change. The hyperparameters which are using for the training purpose, that totally makes a difference. So you have to track it. Like what were you where were you keeping it? I will walk you through Azure Machine Learning Service. Everything which you see over here is already provided in that one tool. So that tool provides all these things. The entire run history of the experiments, like previous failures and success and so on and so forth, with all the logs and all the tags, the continuous measuring of the quality of the teamwork, the CI part. Early termination is very important. Now, if the if you're training, if you're doing algorithm selection and you're training multiple algorithms at the same point in time, then uh, and if you want to automate that, you can put the early termination strategies, like some sort of like when if it is going below some threshold which you have mentioned, the subsequent training runs of that particular algorithm or of that particular hyperparameter will not be continued, and early termination happens. So you will save your time and the compute resources as well because of that. Now, if I take you further, this is very important over here. The continuous integration should also have the model training as part of it. So I'm pretty sure you guys know what is DevOps, but I'll just take maybe another 1 minute over here to just put things back into the simple DevOps practice. So we have the CI pipelines right over here. So let's say this is the CI pipeline, as the build will happen as part of this pipeline in the normal DevOps phases. And let's say this is the CD pipeline, the continuous delivery one. And if it goes to production over here, this is the continuous deployment, like that. So this represent continuous deployment, and till here it represent continuous delivery, and this is continuous integration over there. And the artifact out of this will be the trigger, or can be the trigger for the next one. So this is the CI, and there's a continuous delivery, and this is continuous deployment over there till the end. So as part of the CI pipeline, the model training should happen over there as part of that. So we call it as continuous training. So the when the code change will happen, train your models, keep the artifacts, create the artifacts, and then you can say keep it in the repositories. Now, another very important thing which I want to show, which I am not sure where it went, but I will simply mm, see it. I'll just let you know. Maybe it is somewhere over here. Yeah, over here. So this is one strategy which we use typically. So the like for example, one of the challenge with the with machine learning is that the new model which you are training may or may not outperform the old model which is already deployed. So the new models are called as like champion models, and this is a tag which we use in the when we save the metadata of the model, we save these tags as well. So like champion models are there, which are like the challenger model. Sorry, this is the one which is already deployed, and the challenger models are there. These are the ones which are going to challenge or may not I outperform the old one. So the test which we will do before we you can say register the model or before we deploy something new in production will be between the champion and the challenger as such. And if the challenger outperforms, then also don't replace the model right away, because it is possible the challenger model is having more you can say infrastructure footprint. Maybe it's bigger in size. It needs you to have maybe two core over there, or maybe it needs you to have more RAM and so on and so forth. And the previous model was a champion model in production, which was maybe smaller in size. And if you cannot directly replace it over there, you still have to do integration testing as part of the deployment, even after the challenger becomes better than the champion, because if not done, maybe it will bring down the production system over there. So first make sure the challenger is better than the champion, and then challenger is also we are able to run the challenger in the same environment where the champion right now is deployed. So okay, now couple of interesting things. Let's go in the technical part now. So all of this is just theory around the uh, you can say around the MLOps, but let me take you to the to one. I just want to walk you through one diagram, and then I will show you how we can implement it. Okay, so check this out. This is the flow of MLOps, a little more detailed flow over here as such. And I think I will I'll do one thing. I will switch my screen. I will move this to the bigger screen, the secondary screen which I have. So I will be able to zoom in over there. So I'll just quickly switch the screen to the other one, and we will zoom in there. Okay, so check this out. Now, basically, this is how the flow looks like. And don't worry about it. Just follow my, you can say, steps. So we have the various, you can say, the legends over here, or various stakeholders are here: data scientist, data engineer, the software or the operations engineers over here. Business stakeholders are there. Like primary concern is the primary concern of whom? Like the step is supposed to be the biggest headache for the data scientist, or is it the headache of the data engineer? Right? Secondary concern will be like the primary. If the primary concern is of data engineer, the secondary concern might be of data scientist, who's the you can say the main, who will take care of that particular step over there, who's the main stakeholder. The business flow is there. Let's go through the business flow. Data engineering flow is there, like the ETL flow, ETL, ELT, and the model code flow is there. So let's go through the business flow. So it starts from here. The business goals are there. So as part of the business goals, we define the problem statements, we define the KPIs as part of the hypothesis, which uh, we are trying to do the assessment for these business goals and so on and so forth, whether we can achieve them or not. So the business stakeholders are here, and all the team members are there: the data scientists, data engineers, and the DevOps engineers, or the software engineers over there. So all of them are part of this flow. Now the we are just following the pink line right now. So that the business goals. So business goal will be about the experimentation. The business will look for results. Business will also look for they would like to observe what has happened. Like the dashboarding should be there. Model performance dashboard is not their main concern, but the business performance dashboard is their main concern. So we have to provide them that one. And there are other dashboards which the business stakeholder is not that responsible for in this point in time. Now, if you see that everything starts from, so this is where we have the key steps. So if you think about machine learning, experimentation, building of the pipelines, training of the pipelines, release of the pipeline, and the batch scoring and real time. And that's the business application over there, where the real time business application is coming from that step over there. So I'll just quickly find my whiteboard. Sorry, the graphic pen which I uh, use. Let me see where it went. And okay, so great. Now, okay, so I'll just put some pointers here. So this is where. Oh, sorry, too big. So check this. So let's say experimentation, and then the next one is the build, training, and then release, and then batch scoring. It is multidimensional. It will be difficult to understand, right? So just think with me over here. Experimentation, building, training, release, and so on and so forth. Okay, the first problem, to experiment, you need data, right? You need the experimentation data over there. So the experimentation data might be available on premises, might be in AWS, might be in GCP, might be in some other location as such. So somebody has to get the data to us. So maybe this is another cloud or another, or maybe in Azure, another region altogether over here. Maybe we have other clouds over here like this, and maybe this is on premises. Or data might be coming in streams as such. It might not be coming in batch mode. It's totally possible. So we have to think about some batch ingestion or some stream ingestion solution over there. So we have to involve the data engineers to help us in that this particular phase itself. Like data engineers will be responsible for getting the data from the sources. They may have to install some agents on premises to be able to pull the data from there, or they may have to do the integration to Azure sources, or they may have to do the integration to other clouds to get the data uh, to us over there. And if the data is coming as streams, then they should have some sort of a stream ingestion solution like Apache Kafka or Event Hub or IoT Hub. And then once the data is coming, it is going in some data source, and which that data source is the one which we are going to use as such. So we right now are the data scientist. So let's say we are going to use over there. Now that's not all. Experimentation is just one of the phase. Data is also required. So experimentation over here is the one where you will simply say either it is possible or not. If it is not possible, uh, we cannot meet the business goals and it's end. But if not, then let's say the training data is also required, and the we also need the data for the scoring purpose as such. We also need that in various phases. So the data engineers will be helpful for us to create these pipelines. And these pipelines can be, you can say, will be doing the data preparation for us, will be doing the data validation for us. We will be, you can say, data scientists will sit with them and help them out with what are they looking for, which features should be dropped, which features should be added, what should be splitted, the JSON input should be flattened, or what column should be merged together, and all those things can be done. And we can use the tools which we have in Azure, like data factories and Synapse pipeline to you can say automate a lot of this step with the help of data engineers over there. So finally, the data which we want in the way we want will be available to us in the various phases. And in we can also have like different you can say directories from where we are pulling the data. So apart from this, you can see that the model, the code flow, or if I just put it over here, the ML machine learning flow will be like this. So let's say the bigger steps are here. over there, but the bigger steps will have individual steps inside it, like the code repository, unit testing, continuous integration will be there. So we have to sit with the software or the data engineer or the operation engineers over there who will help us in creating these DevOps pipelines over there. Somebody who is an expert in you can say Azure DevOps dev.azure.com, or maybe with GitHub Actions as such, who can help us out. Then the training part is where the data scientist will take the lead back again. So with the training data, the code will be done, hyperparameter tuning, trained model, the results will be there. Then as part of the release pipeline, data scientist is taking the side seat over there, and the software engineer comes back in, publishing of the model, integration testing over there, continuous deployment of the model. Now, if we are doing a batch scoring, then scoring data, some model output, real-time model, then some API endpoints will be there, and then the integration with the business application. And if I zoom out over here, uh, the retraining, for retraining, we have this concept called as Azure Data Drift Monitor. So we'll put it here, Azure Data Drift Monitor. So this is one service which is part of Azure Machine Learning service. What this does, it works on both source of the data and the live data itself. So for example, the data which is coming over here, right? This one. So what we do, we simply add one instrumentation key over here in the model file itself. So what it does, we start the logging process. So all the inputs which are coming and all the outputs which are going back, we log them into things like data lakes or storage accounts like that. So this is the target data like that. And then the source data is, let's say, over here. So then the data drift is calculated between the source and the target data over there. So the data drift is calculated in terms of so this is the baseline data. So baseline is the data on which either you want to do the comparison with the target data, or either it's the data on which you really have trained the model over there. So the difference is calculated in percentage, like how much percentage drift has happened, let's say 10% percentage. Then you can decide that how much is the tolerant percentage drift over there. The second thing which we do is we don't log. If we this happens is mostly in, can say, in, let's say, real time scenarios. The other way is that if you are getting new data, imagine from the batch processing point of view, new data came next month. So the old data which we have, uh, let's say, versus the new data. So is there any need to do the model retraining right now? Do I need to retrain my model? If the data pattern has changed, I will have the need to retrain my model. Otherwise, if let's say if the data has not drifted, then you don't need to trigger the model retraining pipeline over there. So now this is the overall flow of it, and I'll give you the link in the chat window from where I am showing you this. So in future, you will be able to uh, do that as well. Let me see from where did I copied it. I just copied it for you, and I am looking in my secondary screen right now, or that link. Okay, the it's on the page which I'm sharing right now. It's on the bottom of that page, right? Find it from there. Okay, so now the practical part. How do you do this? How do you do all of this, right? So now the creation can be done with. So we have two DevOps tools right now in Microsoft. You can say ecosystem. One will be the Azure DevOps portal, dev.azure.com. Other one is GitHub Actions, the new ones. So if I show you how it's done, I just have to uh, take you to my repository, and let me open the Azure portal as well. So over here, and I would like to share one template with you. It's going in the chat in another 1 minute. So it's called as Enterprise Machine Learning Template. It's provided MLOps template for enterprises. Please bookmark the last link which I have pasted. Right. So it's over here. That's what I have pasted in the chat. It's from Microsoft, and it's basically called as Enterprise Template for MLOps. So it is having the standard baseline thing which you need to create with steps to accelerate your MLOps processes as such. Now, can we implement MLOps without DevOps? Answer, without Azure DevOps. Answer is yeah. We are. So I'm just showing you the example where it is used with GitHub Actions as such. You can use any other tool. It doesn't matter. The practice remains same. Tools can be of your choice. So now, so please bookmark this link which I have just pasted in the chat. Go through this. And steps are also there. It will take you some time to understand it, but it's called as the enterprise template for MLOps. And let's have a look at it, what we have done. So I'll walk you through a couple of things. The code structure which I showed you, the folder structure which I showed you, I have that same folder structure with a few variations over there, and as such from it. And I'm using the same template which I just cloned, which I forked from their repository, and I have. I just want to show you a couple of interesting things. So let me open a couple of things over here, and like this. So this I'll explain in a second. Let me start from something else. Okay, check this out. So I have this code directory over here, which is having the deploy and the training part. Two main things which we are using right now. So let's click on the training part. Now in the training, we have the environment.yaml file, run configuration, and train.py file. Let me walk you through all of these files. So let's go through the model training part where the model is trained literally, right? So there is nothing special over here. In this one, it's a simple scikit-learn experiment, and we are using support vector classification (SVC) part of SVM, and it's just doing a classification. Nothing special in the training today. You can check any previous sessions for any deep learning and so on and so forth. So this is how your model code will be there, but it should be, you can say, modular, and you should have functions and so on and so forth. Uh, and if I just take you back, the other important thing is the environment file over here. So as part of the environment file, the training environment is there, which we are going to use in the MLOps pipeline. So the training environment is having some dependency, 3.7 scikit-learn dependencies, and so on and so forth. Some basic things are there. And if I take you back, this is a very important file over here, run config file. Now, what this run config file does, this is the file in which all the parameters are versioned. You remember we were talking about that code versioning, the dataset versioning, and the parameter versioning. This is more like the parameter versioning over there, where the configuration of what we are going to submit as part of the run will be there. So we are submitting the train.py file. It is running on one particular cluster which will get created on the way. Python framework is there. One node will be there in the cluster. uh, User will not manage a dependency. Cloud will manage the dependency as such. The environment file is the YAML file, which I was just showing you before opening this. This one I have taken from them only. You can look up like that. You can go to their Microsoft's MCR is Microsoft's container registry, and you can go to the catalog over here to find the other images as part of the catalog. So all the images are here. So for machine learning purpose, you just have to do a Control F there, uh, Azure ML slash base images like this. So any ML oriented images will be here, which will be useful for us. Like front end for any Kubernetes deployment images are here, and right, MPI is basically the message parsing interface. If you're doing something for deep learning, then this is something which is very useful for you. And OpenMPI is the open message passing interface. We were having this one session last week on the distributed machine learning using Horovod Spark, where we were using the MPI. So those who are interested in that, you can just watch the last week's session. And one of these base images is what I selected over there. I am not able to find it right now. It's just in this list only. Now, basically, if I just take you back, now other things are not really important over here. These are some default parameters were there where I didn't make any change. I just left it the way they were. But in case you want to do any Spark based training, or if you want to do any HD Insight Azure, let's say Hadoop cluster based training, or you want to do any training on the Spark cluster and so on and so forth, then you can also use that option. And if you're doing some sort of TensorFlow distributed and you're looking for the parameter servers and you're looking for the MPI and all those things are available, how many parameter server will be there? If you have less parameter server, then the network will get choked. If you have more so if then bottleneck will happen. If more parameter server, then network will get choked and XYZ. So all these things are also there. Now, if I just take you back, so we maintain the everything. You can say all the steps will be maintained as part of the files over here, and want to show you the deployment part as well. Now, these two files are very important. These I'll explain what these are doing. Let me just show them first. So this is the environment file which is used when the model is deployed in the container. It is the one by which the container image and the final the Docker image and the final Docker container will be created. This is that file over here. So this is equal to the Docker file. Like if you know Docker file, this is equivalent to that. So it's exactly similar to the one which I showed you previously. Not exactly same, but it is not having matplotlib, and some of the plotting libraries are missing because we don't need them. So those we have not put them over here. Uh, and if I take you back, this is the most important file, maybe one of the more important file, maybe not the most. But what it does, this is the one which is finally supposed to be there inside your uh, Docker container when it is deployed in the production. So this file is also called as the entry file, or this main file, or the entry file. Or what it does, it contains two functions over there: the initialization function and the run function. And basically, the initialization function, init function, it loads the model into memory. Whatever the model you may be having, that model will be loaded into memory back again. And then the other function which we have, the run function, this will do the model dot prediction. So the data which is coming over the API call, this will put that into an array, and then we'll do the model dot predict and we'll throw the output back. We can beautify the output here where I'm moving my cursor. You can say before you throw the output back, you can add some maybe labels to it and so on and so forth, or maybe some more text to it over there. So this file runs is there inside the final deployed location. Now, I want to take you back to the infrastructure over here. Now we are using, as we were discussing, infrastructure as code, right? So you will see that we are deploying the infrastructure as part of the JSON files, and this is the parameter file for the JSON file. So this is called as an ARM template or ARM template. If I click on this one, uh, you will find that we are this is the it's a typical ARM template, but uh, what it is doing, it is deploying a couple of things: one storage account, one application insights, one data lake, uh, one machine learning service, key vault, and event grid as well for event passing mechanism, like trigger based solution. So if something happens, then something should happen. So for that trigger, we are also using event grid over there. So this one will be the one which is deploying the infra for us. So how is it triggered? I'll just show you that, but let me show the infra first. So I already kept it. I already triggered this in my RG MLOps production East US. So it creates these. You can say this infra over here. Some of the infra has been created by the deployment file, but just to give you an idea, see the application insights, container registries, event grids, key vaults, AKS is the final deployment target which we are using, and the machine learning services over here. So now let's go through some of the interesting part. So how does it work, right? What is the flow of it? Step one, step two, step three. Let me explain that part. Before I go in that step one, step two, step three, just want to show you this as well. Like we are deploying, the final deployment location is Kubernetes. The testing location is Azure Container Instances. The training cluster is created over here. Registration of the model is done by this script, this one. The parameters are there over here. If I click on it, like what's the name of the model and so on and so forth. over there. The run.json basically involves what are we running, which pipeline, and so on and so forth. The and so on and so forth. Okay, so let me take you back to my whiteboard. Oh, sorry. Let me take you back to my whiteboard and let me explain what are these. That's the main CI and the CD part over here. So to do all of this, what we have over there, we are using GitHub Actions. Now, GitHub Actions are the other new ones which you may have heard about. Now, as part of GitHub Actions, there are a couple of things which we do. So imagine this is the workflow of GitHub Action. You see this workflow like that. So this workflow is the one which I was just showing you, one of them. You see, like for example, imagine the setup.yaml, this one. This is that over there. Now, the what this workflow will will have different you can say uh, you can say the uh, let me just show something before. So if I just open this setup.yaml, see, check this out. So basically the name of the workflow, infra, deployment, and training. It will get triggered. It will get triggered when any push happens in this file over there. The environment variable is my resource group name. One storage account which I want to create, that's my resource group name over there. ADLS as such. It is running on one runner, Ubuntu latest runner over there. And then it is having various, so as part of the job, we have these steps over there. See, one step, check out from the repository, login, Azure login is second step. Third step will be deploy to Azure. And what to deploy to Azure? The template which I was showing you before. Deploy that template to Azure. So if I take you back to my whiteboard and if I just decipher this same file over there, so the red box over there is representing the various steps which are going to run, and these are my steps over here. Let's say step 1, step 2, step 3, and step 4. Four steps are there. So like the code will be checked out, and then the Azure login will happen. Then mm, after that, the third step was basically only 3 steps are there. Deploy to Azure. So the last one is not there. And the third one will be deploy to Azure, like the third one over there. So these individual steps which we have, you can have scripts over there. You can write your scripts yourself and you can run them as part of those steps. Otherwise, these steps we can use the actions which we have as part of GitHub, called as GitHub Actions. So GitHub Actions are the ready-made, you can say scripts or unit of work which will be done for you in this manner. So as part of and as part of the workflow, something has to trigger it. Like so, one trigger will be there, trigger, and this all these steps will execute in sequential manner like this. Now the when they execute on a runner. So runner is the agent on which it executes. So which is the Linux machine right now, Linux. So which we have defined over here, that the runner is the Ubuntu latest machine over there on which all these steps will be executing. Now, so the first workflow which we have is the one which will set up the infrastructure for us. So if I show you the executed one, so it basically will show in this tab, Actions. So when you work with GitHub Actions to create your CI/CD pipelines or MLOps pipelines, it is supposed to be in .github/workflows folder. If it is not there, it will not run. So now as part of it, you can give any other name, but it should be in these two folders. That's the way it works. Now, so I have some of them are executed, some of them have failed. I kept the failed one also just to show you. Things doesn't work always correct. Now, mm, setup should be this one over here. So that's the first one, the setup.yaml file. What it does the setup. So uh, if how does it look? So this has already executed, but what it did, it took that ARM template which I was showing you earlier, and it created as part of infrastructure as code. We were maintaining the ARM templates and the versions of the ARM template, and that ARM template was used in this pipeline to deploy all the resources which we require in the in one of the environment. So this is like one-time job. Like you have to create the environment, or until unless if you are cleaning the environment later on, then you do something, you do the testing, and then you clean the environment. But if you think about the production environment, if you're creating that through IAC, then it's like one time, or maybe incremental changes will be there, and so on and so forth. So this is the first step where we set up the infrastructure. So the first GitHub workflow execute, it creates one AML service, AML, Azure Machine Learning service. It creates one storage account where data will be kept, and it creates some of the compute clusters over there inside it. Only one node is there in my diagram. I'm making 4 nodes. It looks nice in the diagram. So this is the cluster where the training will happen. This is basically the storage account where the data will be kept over there. And this is the AML service where all the things are tracked and kept. So the first workflow basically creates that. The second one executes when the data scientist will do the code commit in the code repository. So if I if I go one page back uh, and show you the other file over there, which should be the one which call as training of the model here. This one, I executed this around 5 hours back when I was setting up the example. And if you see this one, it basically is going to get triggered. So you see this on basically represent in the GitHub action, like when that what will trigger it. We have to define the triggers here inside on. So it will get triggered either if anything happens in the code folder or if anything happens in this file itself. So if I make any code change here, it will trigger again. And then we have some sort of HTTP request also there. I just added this. I never completed that. So the job which we have is having these steps over there, and the steps are we are doing the model training right now. So check out the code from the repository, connect to the machine learning workspace, and then submit the training run over there. After that, 3 steps are there as part of this workflow. Now, before this workflow can execute, I had to do a little bit of setup. So imagine this is the second workflow over here, and which is having that one single job, and that job is having 3 steps over there. So 1, 2, 3, like that, like this. So to make it work, because the GitHub action, GitHub will not have any rights on Azure. So what we have done, the block box which I'm creating is representing Azure subscription. So what I have done is I went to Active Directory of Azure and I created one service principal. That service principal I gave the rights on the subscription, and that service principal is what I have added in the secret section of my repository. So if I take you back and if I show you, if I just scroll up and if I take you one step back over here, and if I click on the settings over there, this is something which I've already configured, secrets. And as part of the secret, I have created this Azure Credential is the name of the secret. And as part of the secret, there are 4 information. The tenant ID, the tenant ID is the directory ID, my Active Directories ID. The name of the service principal is there. The over here. So service principal, if you don't know what this is, you can think it through like the representation of your application, or it's like the service account. So there are some secrets which I have kept in that secret section of this, the IDs of it, and some other you can say identifiers of that. So all of those things are already in the secret section, which the steps are right now using to do the model deployment. So what they basically do, they pick up the train.yaml file. And they take that run. Actually, they don't. It picks up that the config file which I was showing you earlier, and it uses that config file as part of the step to do the model deployment. So all the parameters plus the code file, train.py file, everything is version controlled and is used to submit over there. Now the second one is over here. Now the third file, the deployment file. If I take you one page back, the deployment file actually depends on the next previous one. So this is the one which does this is infrastructure as code. This is the one which does the model deployment, And the last one is the one which I have over here, which is called as deploy model .yaml. This is the one which is depending on the success of the uh, of the model deploy of the model training. If it is successful, then it will run. If it is not successful, then it will not run, basically. So these keywords are already provided by the you can say GitHub Action platform. So same thing happens here. We do the runner is Ubuntu latest. So this is the same runner. The version is the same one for the third workflow as well, which I can put over here. So this is the one which where it is executing, and the third workflow is the one which does the the deployment of the models. So over here, like this. So the software engineer, or you can say DevOps engineer, will help you out in creating all of this. But if you can see, uh, we check out the code. We connect to the machine learning workspace. This is where we are deploying the Kubernetes cluster, and this is where we are also deploying the ACI instances. Then register the model as part of it. And we can also use the previous steps. For example, say github.event client payload dot run ID. So you see these IDs as such. With these IDs, you can use the individual steps in the next steps. So AML underscore workspace can be used in the next one, and so on and so forth. So from the previous one, from AML model register, which is over here, we can use the name of the model or the output of the model, like that. So deploy the model to dev environment. So dev environment is the ACI environment, container instances, and the final production environment is the AKS environment. And whatever we are doing over here, everything is parallelly happening in the Azure portal. So if I take you to this is the Kubernetes cluster where the final model is running. If I take you to the machine learning workspace where all those steps are executing, this is where it happens. So the underneath the experiment, all the experiment will be logged, all the failures, all the success, the entire run history. If you click on any one of them, the all the logs will be there. What was used to train it, who ran it, when it was executed, what was the accuracy, the best practices which we are discussing about. All those things are being followed right now. The what matrices were there, what were the outputs of it, the logs were there, what errors came, how the confusion metric looked like, and and so on and so forth over there. So and the compute cluster is this compute cluster which we are using. It's still running, and the the models are hosted here or are registered here. So this is the model registry as part of the MLOps practice, where all the tags are available uh, over there, and and the data sets are here, but I didn't configure any data set right now. So, but you can think it through over there. And we can do the data drift monitor is not configured yet, but data drift monitor is configured from here, from where we can do the comparison of the data set. So the retraining pipeline can be triggered over there, like this part can be done, this and that. So this is this is what I had set up for the session, where we are we have seen the flow of but it's a pretty complicated stuff, right? There are a lot of moving parts over here, multiple different domains and multiple different teams they need to interact with each other. But this will give you an understanding of that it is not that different from DevOps, but it is having the complexity of the data science, which involves the retraining and the experimentation before you can do any you can take any things to the production, and how can you combine all of it as such. Now I'll put the links again in the chat window. Please bookmark these links. These links are useful for you to deploy things in you can say in production. I will give you uh, I'll so all the links which I shared earlier, I'm just putting them again in one go. So if you have not bookmarked it, please pick it up from the chat now. So they involve the templates which I was showing you, the production templates, and the best practices and anything which the maturity level of your teams and MLOps processes. All of those things are there. And after the session today, when you want to reproduce what we have covered, you will you can also go to the learning module as well, which is here, and it is also going in the chat over there. So if I open this one like this, so this is where things are in available in a structured manner as well, and you can go through this learning module as such. So this is what I had planned for you, and it's just an introduction as well. Uh, so please, you can ask your questions. Let me go through the the uh, the chat window. There is one question in the chat saying the next session is in June. Yeah, there is another MLOps session which is coming in June. We will be that will be a workshop of 3 hours. So yeah, 3 hours workshop. You can unmute your mics and you can ask your questions as well. All the diagrams, all the links are in the chat. Please bookmark them.
Yeah, you can unmute your mics now and ask the questions.
Right. Okay. So you can also find me on LinkedIn. I'll be available for your questions as well. You can ask your questions. We can engage on any technical or non-technical topic as well. So my LinkedIn profile is also in the on the meetup page, and let me know if you get stuck in any MLOps project and you want any, you can say, help in that, then you can find me on LinkedIn.
Any more questions, guys? Let's call for a wrap up. Shivam, what say?
Right. So, okay, then the please put the link where they can join us. They can check the recordings as well
I'll
in
share that
the
link.
chat, right? Okay.
Yeah, I'm sharing you the link. I'm
The
sharing you
recordings,
the link, LinkedIn group, Reactor group, the recordings. Yeah. I've shared the link. Yeah. So the first one is the LinkedIn group. Second one is the Reactor meetup page group where you can find upcoming sessions. There is a Reactor YouTube channel link and there is today's learn module link. So let's wrap up, Shivam. What's it?
right? So we can wind up as well. So thanks
Yes.
everyone. Thanks Parth,
Yeah.
and we'll see them in the next session.
Thank you, Shivam, for the session, and thank you all for joining us today. Please do share your
Yeah, thank you,
feedback
Shivam.
about today's session. Also, feel free to use the Learn module link shared in the chat section. This will give you the access to the additional resources to take your learning further. Please also visit our Microsoft Reactor Bangalore meetup page for more upcoming sessions. Thank you all once again and enjoy the rest of your day. Thank you, Shivam, for the amazing session.
Thank you. Thanks everyone. Bye bye.